Okay, guys, one last lesson to talk about here. We're going to talk about today. We talked a little bit in our last lesson about what inflation was and why it's so dangerous to an economy. And for this lesson, we're going to finish up by talking about how we calculate inflation. All right. This is probably the most math that you're going to do actually through all of macroeconomics, and I feel badly that it's one of the first lessons that we do. But if you're stressed about math, this is probably the most math we're going to have to deal with this semester. So don't get too stressed. Get through this lesson, and you're going to be just fine. Okay? All right, here we go. Let's talk about a couple things. The first thing we're going to do is we're going to talk about how we actually measure inflation, and we measure it with something called a basket. And what a basket is really simple. It's a group of goods and services that make up a cross section of the economy in any given year. So what they really are is economists choose a bunch of stuff that's very common in the economy. Now, obviously, we can't measure the price of every single good in the economy. There's tens of millions of goods. It'd be too complicated. So what we do is we pick a few thousand goods that are very common, things like gasoline and milk and clothing and things like that, things that everybody buys pretty commonly. And we put them into what we call a basket. And what we do is from week to week and year to year, we measure those same products to see how exactly it is they add up. And if the prices overall of that basket change, then we either know inflation is occurring or not occurring. All right, now here's how we calculate a basket, and it's really simple actually. Suppose this data here reflects the country of Hooplandia. All right, now Hooplandia, we have three goods in our basket. We have Oreos, economics books, and dry erase markers. Seem like pretty reasonable things. Everybody would want them. Okay, now you'll notice that in order to calculate the value of our basket, we have a couple things we have to do. The first is we take a look and we see that the price of Oreos is $1. The price of economics books is $10, and the dry erase markers are $3. Now, it doesn't really make sense for us to count economics books the same way that we count Oreos because we only sold 5 economics books. So if the price of economics books changes, it shouldn't say as much about inflation as it does if Oreos change because we sell a lot more Oreos. So in order to take in the factor of how many we sell, we basically look at how much total money was spent, P times Q. So for Oreos, we spent $100. Economics books, we spent 50, 10 times 5. And dry erase markers, we spent 75, 3 times 25. All right, so here's how you figure out the value of your basket. First step, figure out how much was spent on each good, which is what we just did. $100, $50, and $75. And then step 2, add up all those together. And unfortunately, it looks like my screencast cut off the answer. You can see the very top of it at the bottom of the screen. But it's $225. 100 plus 50 plus 75. Pretty straightforward. Okay, and now we have the value of a basket for Hooplandia. Okay, so again, to calculate a basket, take the price of each good, multiply it times the quantity. That gives you how much was spent on the product, and then add those numbers all together, and that's how much your basket is worth. Okay, once you have the price of the basket, you can find something very important, and it's a phrase that we absolutely should know, and it's a phrase that all economists, in fact, really anybody who is even a reasonable citizen of the country and knows about what's going on is going to know this term. It's what's called the Consumer Price Index, but everybody calls it the CPI. And if anybody knows what an index is always really something that measures something. Okay, in this case, we're going to be measuring inflation. And here's how you calculate the CPI. By the way, first of all, what is it? It's a 100-point system that measures inflation. So 100 is kind of like the base. And if you go higher than 100, you know that inflation has occurred since that point. And if you go less than 100, that means that deflation has occurred since that point. Okay? And here's how you calculate the CPI for a certain year. The first thing you do is you do the price of a basket in what's called the target year. Now this gets a little bit confusing, but the target year really is the year that you're trying to convert to some other year. And the some other year would be what's always called the base year. Now it gets a little bit confusing, so maybe an example would help kind of clarify what I mean by these two things. All right. So here's the definition. A base year is the year that you will adjust all your other prices to match. Whereas the target year is the year that you want to compare to the base year. So put it in different ways. The base year is kind of like your fixed variable, and the target year is sort of the thing that you're changing to match the base year so you can make a comparison. And here's a better example, I think. If I want to know how much A-Rod in 2010 would have made in Babe Ruth's time, 1930, then 2010 is the target year, and 1930 is the base year. Okay? But by converse, if I want to know how much Babe Ruth would have made, Babe Ruth in 1930 would have made playing today in 2010. Now 1930 becomes the target year, and 2010 is your base year. So the base year is the year that you're going to convert everything else to kind of match. So if I said to you, how much would a candy bar cost today how much would a 1973 candy bar cost today? 1973 is the target year. Today is the base year. All right. You don't have to get crazy with this, but it kind of helps you understand what it is we're talking about here. How do we calculate the CPI? CPI is really easy. You take the price of a basket in your target year, divide it by the price of the basket in the base year, and then multiply times 100. Pretty straightforward. Okay? So, for example, let's take a look at Big Macs. If a Big Mac cost $1 in 1980, the base year, we're going to call it in this case, and $3 in 2010, our target year, what would be the CPI of the target year? Now, here's a little tip, by the way. The CPI for the base year is always 100. That's because it's based on a 100-point scale. So the CPI of 1980 is 100. So if I want to know, has inflation occurred since 1980? If it has, my CPI is going to be bigger than 100. And how do I calculate that? Remember the formula? The price of the target year divided by the price of the base year times 100. In this case, $3 divided by times 100 equals 300. That actually tells us that since 300 is 3 times 100, that we've had 3 times the amount of inflation, or 300% inflation, since 1980. Quite a bit. Okay, now you try. If an auto worker made $5 an hour in 1965 and $20 an hour in 1990, what's the CPI for 1990? And again, 1965 is going to be our base year, 1990 is a target year. If you want to figure this out, pause this recording now, and then I'll give you the answer. Okay, here comes the answer. Again, your formula, the price of the target divided by the price of the base year, 20 divided by 5 times 100 equals 400. Okay, and that's how you calculate your CPI. By the way, just so you can see why it really does matter, if you take a look here for a second, you'll see that the CPI over time has grown quite a bit. So it actually, inflation, the price of things really has grown a lot. You can see where it's grown in particular pretty quickly. Okay, really quick, just a term that I want you guys to know. It's not a huge big deal, but another index that's used sometimes to measure inflation is what's called the GDP deflator. And GDP stands for Gross Domestic Product. That's actually our next lesson. But I'm just going to mention it now because it's really simple in the sense that it works exactly the same as the CPI. So anytime that you see the GDP deflator, you can substitute the word CPI. They're exactly the same. The only difference is that instead of using baskets of goods to measure the change in prices like the CPI does, the GDP deflator uses what's called the gross domestic product, the GDP. All right. So the basket, in this case, if you're using the GDP deflator, basket would substitute for the word GDP. And the whole thing, GDP deflator, would substitute for the CPI. All right, it's not a huge big deal, and they don't usually ask the GDP deflator, but it's just worth mentioning because it's here. Okay. Okay. Now the terms we learned in last lesson, real versus nominal. I want to go out and show you how we calculate those things. And as you guys can see here, this is an example happens to be of gasoline prices over the last 30 years or so. But you can see why it's really important to understand the difference between real and nominal prices. The top line are nominal prices. And remember what nominal means. Nominal means the actual dollar that's on the price tag, the actual number. Real means that we adjust it for inflation. We get rid of inflation. We pick some year. In this case, it looks like it says 1979 is the year we picked, and we adjust everything back to that so that we have a common point of reference. And if you look at this difference here, it looks like gasoline prices have gone up quite a bit over the years, nominally, and that's true. They have nominally. But in terms of real terms, in terms of what it really means, what you could have bought with that money otherwise, gas has stayed pretty more consistent, the lower line. It's important to see that difference because economists are much, much more concerned with the lower line. We understand that inflation happens. We understand that prices rise and fall, but that doesn't mean that things are necessarily really more expensive. You have to look at the real values to see that. Okay? So how do we do that? Converting to real value. Here's how we do it. It's real simple. Real value is equal to the nominal value. Oh, excuse me, the real value of that year is equal to the nominal value of that year divided by the CPI times 100. So, if Titanic sold $1 billion in tickets in 1997, if the CPI for 1997 was 50, and we're going to use this year, 2010, as our base year, how much would Titanic have really made today? Well, we take our real value, which again, nominal divided by CPI times 100. We want to find the real, so it would be equal to the nominal, 1 billion, divided by the CPI, which was 50, times 100, which is equal to 0.2 billion times 100, which is equal to 2 billion. So if we said today, for example, that Spider-Man is the highest grossing movie of all time, well, technically that's true because its nominal number was bigger because Spider-Man came out well after Titanic did. But the reality is that because when people say that they weren't adjusting for inflation, what we find out is that in reality, the real value for Titanic is actually even more than Spider-Man was if we converted it to today's dollars. So that's why we have to really consider real values and not nominal values. Actually, as a bonus, you guys can find out for me what is the highest grossing movie of all time in real values. Again, Spider-Man 2 is actually, I believe, the highest of all. I'm sorry, I guess Avatar is now. Avatar is the highest grossing of all time now. But is it in terms of real values always been the case? It's not actually, and you guys can find as a little bonus what the right one is. Okay, now you try. Suppose teachers made $20 an hour in 1990. If the CPI was 1990 was 40, how much would they really have made in 2010? And again, I'll pause here if you want to stop the recording here for a second. Try the problem out, and then I'll give you the answers. Okay, here we go. Again, here's our formula. It's the nominal value divided by the CPI times 100. 20 divided by 40, nominal value divided by the CPI times 100 equals 50. So the real value teachers made in 2010, in 1990, the real value, if we were to compare that to today's dollars, would have been $50 an hour, which is not a bad salary. Okay, and the last one. This one's pretty easy because this is one that you guys have done before. The inflation rate. First thing we should do is define it. The inflation rate is the percent change in inflation from one year to the next. Okay, you cannot have an inflation rate that covers 3 or 4 or 5 years. It's only moving from one year to the next. So whatever our inflation was in 2010 compared to 2011, that's our inflation rate. We can't compare 2010 to 2012. And the good news is, like any other problem that's a percent change, we've done this before. It's that whole new minus old over old thing. In this case, though, the value is your CPI. So real simple. The inflation rate is equal to the CPI of the year you want to find out about minus the CPI of the previous year divided by, let's see if that comes back in. There we go. Divided by the CPI from the previous year times 100%. Okay, and so for an example, if the CPI in 1990 was 100 and the CPI in 91 was 110, we take 110 minus 100 divided by 100 times 100%, and we find out the inflation rate was 10%. Okay, I'm running short on time on this recording, so hear it real quickly. That should about do it. Guys, take some time to practice these. Look at this one a couple times. It is tricky and complicated, so do these 2-3 formulas a couple times, and then try the practice chart that I put up for you guys online. Okay, see you later.